Hello, Math 1020 class. I want to do another Nspire video, but this time I want to use some of the document features on the calculator instead of just the scratch pad. But essentially, we're going to do the same problem starting with number 4 from chapter 2, review. As the table shows, projections indicate that the percent of adults with diabetes could dramatically increase. Part A says, find a linear model that fits the data in the table with x equals 0 for the year 2000. So how do we use the document features to answer that question? We'll just go all the way down to the bottom and choose lists and spreadsheet. And this is how you enter the data values. So in the first column, you want to enter your x's. And in fact, I'm going to go up to the top and label this as my x column. So x is the number of years after 2000. The first year I'm given is 2010. So that would be 10. The first x value. It looks like they go by fives. All the way up to 50. Now let's go ahead and input the y coordinates. And I'll call this column y. Okay, so how do we find the regression equation? Well, first of all, I'm going to go ahead and move over to a new cell in the third column there. Well, the way you do it is press menu, go down to statistics, and choose stat calculations. And we're looking for a linear regression. So we'll choose that. And you kind of have to tell the calculator that the x coordinates are in column x, the y coordinates are in column y. And notice, by the way, this is going to save this function as f1, which is kind of nice. And that just says that the first column it's going to put in the new data in is column D, which is okay. So press enter. So there's the regression equation, is y equals mx plus b, where m is 0.507. And if you want more accuracy, you can always highlight the cell. And the constant is 10.769. So that's part A. Part B used the model to predict the percent of adults with diabetes in 2013. So just keep in mind that the calculator will remember this function as y1. So when I'm ready to do something with the graph of it, I'm going to click Control Doc. That'll create a new page, and I'm going to choose Add Graphs. So notice if I go back up to function f1, it's already in there. So I can just press enter and it'll graph it. Not a very good picture, but that might be good enough for what we're about to do. It says use the model to predict the percent of adults with diabetes in 2013. Well, in this problem, x is the number of years after 2000. So we're looking for the y coordinate when x is equal to 13. And what we could do, I suppose, is just go to the table. So I'm going to press menu and scroll down to table, split screen table. And let's just go all the way down to x equals 13. And notice the y coordinate for that is 17.4 to the nearest tenth, so the answer is 17.4%. That's part B. Part C says, in what year does this model predict the percent to be 21.92? Okay. So notice they give us the y coordinate is 21.92, and they want us to find the corresponding x value. So first of all, let me get rid of the table. So I'm going to press menu, go down to table, and remove table. And now I'm going to go ahead and enter another function. I'm going to graph another function. So go to menu, graph function. And the second function I'm going to graph is the constant they gave us, 21.92. So press enter. And the window is needs to be changed because I can't see that horizontal line or very much of the regression line. So let's go back to Menu, Window Settings. So what would be a good X max? Well, my X's go all the way up to 50, so I think X max should be probably 100. And I think we want to change the Y max too. My Y maxes or my Y coordinates go up to 34.9, so I'm going to change the Y max to 100 also. Now we'll press OK. So we get a pretty good picture. You really just have to find the point of intersection of the two curves, and then the X coordinate of that point is the answer. So let me go back to Menu, Analyze Graph, Intersection, and just move that vertical line a little bit to the left of the point of intersection, press Select, move it a little bit to the right of it, press Select. So to the nearest integer, the X coordinate is 22. But just keep in mind, X is the number of years after 2000, so this is really the year 2022. That is the answer to part C. Well, let's move on to number 6 from chapter 3. All right, and by the way, if we want to delete that entire document, I don't really see any reason to save it. Just click on this button to take you to the home screen, then go over to Browse under Documents, select it. So notice we have an unsaved document there. How do we delete that thing? Just hit Control, Menu, and then Delete. That'll take it out of there. So that way we can start from scratch for the next problem without having an unnecessary document. So let's do this one. Find the equation of the quadratic function whose graph is a parabola containing the following 3 points. So this is just another regression problem. I can pretty much do exactly the same thing I did on the last problem. It's actually a little easier. So let's create a new document that is a list or a spreadsheet. And once again, I'm going to go ahead and label this first column X and enter the X coordinates of the 3 points that I've been given, -3, 1, and 2. And here's my Y column, 31, -1, and 1. All right. So once again, go ahead and scroll over to the third column. That's where we're going to put our regression function. But go to Menu, Statistics, Stat Calculations, and this time we're looking for a quadratic function. So X list is X, Y list is Y, and this one will be saved as F1. I'm not sure we're going to need it to do anything. We're not going to need to do anything else with it this time, but it'll save it anyway. Okay, so notice that our quadratic function is right there, ax squared plus bx plus c, and they give us the a, b, and the c. So it looks like the function is actually 2x squared minus 4x plus 1. So that takes care of that problem. Let's do number 4 from chapter 5 next. And once again, I'm going to go ahead and delete that document. You can save it if you want to. But there it is. So just press Control, Menu, Delete. So that'll take it out of there. We can start from scratch. Well, this one says solve the inequality 4 to the x less than 4096 or 4096. So it sounds like we're going to have to be doing some graphing in this case. So I'm going to go down and create another document. But let's make it a graph this time. So you want to let the left-hand side of the inequality be your first function, which is 4 to the x. And we'll go ahead and graph that. And the right-hand side is your f2, which is 4096. So we'll just hit menu, graph another function, 4096. So we're not going to see that because it'll be off the screen. But let's just go back to menu, window settings to create a more appropriate viewing window. I think the X-max is okay, but the Y-max, I usually like to double the biggest number that I see in the problem. And in this case, it's 4,000. So I'm just going to make Y-max 10,000. So that gives us a pretty good picture. Now, if it says 4 to the x is less than 4 to 96, the exponential function has to be below the constant function. So just look to see where the blue curve is below the red curve, and it looks like it is in this interval. So you just need to find this point of intersection, and then just say x less than that point, only because I have a strict inequality in the original inequality. If it were a less than or equal to, I'd say x less than or equal to. But just go back to menu, analyze graph, intersection, and just like before, move the vertical line a little bit to the left of it, select, a little bit to the right of it, select. And remember, you can move this point a little if you just click on it. You can move it around. So it looks like the answer is x less than 6. So that takes care of number 4 from chapter 5. And the last problem I want to do is number 2 from chapter 6. So there's really not too much difference. The main difference is you can save these documents if you do it in document mode as opposed to the scratch pad. Well, let me exit out of there, and I'm going to go ahead and delete the thing because I don't want to keep it. So control menu delete. There's one way to delete it. The adjacent table gives the number of worldwide internet users in millions. Part A says find the cubic function that is the best fit for the data. Okay, so it sounds like we need to enter a bunch of data points. So let's go down. Let's create a new document, but this one will be a list or a spreadsheet. So once again, I'm going to label this first column as an X. Those are my X coordinates. And X is the number of years after 1990 in this case. And my first year is 1995. My biggest year is 2007. So the X's go from 5 to 17. So let's go ahead and call the second column Y. Okay, so now let's go ahead and highlight the first cell in the third column. and do what we did before. We're looking for the best fit cubic function, so go to Menu, Statistics, Stat Calculations, but this time cubic regression. And it'll save it as F1. In this case, we might actually want to use the F1 function. So notice that if you highlight the cell, you can see the entire contents of the cell. Ax cubed plus bx squared plus cx plus d, and they give us the a, b, and the c. So there's a, b, and c. So the answer should be negative 0.313x cubed plus 14.163x squared minus 83.992. And we should be careful. It's actually, notice, 0.993 because that would round up. So if you need more accuracy, just highlight the cell. That's actually negative 83.993. And this one is 105.429. So be a little careful about that, about the rounding. This one is supposed to be rounded to 3 places. So part B used the model to predict the number of users in 2013. So just remember, in this problem, x is the number of years after 1990. So 2013 is actually x equals 23. So we're going to need to do something with the graph of this thing. So let's go ahead and create another page in this document. So that's Control Doc, Add Graphs. And if you scroll up, you can see the function that we just found. Go ahead and press Enter. But we really want to go to the table. So I'm going to press Menu, Table, and Split Screen Table. But because we're looking for the percent in 2013, that's for x equals 23. I need to scroll all the way down to 23. Look at the y value when x is equal to 23. And it looks like 1,862 to the nearest integer. And that's the answer to part B. Part C says, compare the graphs of the data and the model to determine if the model is a good or a poor fit for the data. Well, the answer to that one is always good fit because you found the best fit cubic function for the data. So that should just about do it for this video.